guys, this video are going to explain on wildlife formation test. Lesson outcome. By watching this video, you are able to first, describe wildlife formation test. Second, explain wildlife formation test operation. And the third lesson outcome is identify the advantages and disadvantages of the wildlife formation test by comparing it to other formation tests. What is wildlife formation test? In a simple word, it's an electric logging tool that runs downward and pushes a probe into a formation wall. The fluid will then flow into a small closed chamber. The chamber that containing the fluid will stand for analysis. The result of analysis will help in the well performance in the future, which very significant test to be carried out. The test is used to first, obtain fluid sample. Second, obtain pressure profiling along the well bore. The pressure parameter is significant to be known because it will help in the future application in the well. And the third test is conduct transient test. Last but not least, vulnerability along the well bore will be discovered. Horizontal, vertical, and its distribution of the permeability will be known by running this test.
Operation of the tools. This figure is the illustration of the tool. When the tool is being moved downhole, the formation tester is in its retracted configuration. When a depth is selected for a pressure measurement, the formation tester is activated and hydraulically set or pressed against the formation. This condition are shown schematically in figure 1. Turn to figure 2. Two modes of measurement exist. The first one, a pretest measurement in which formation pressure are examined. Second, a fluid sample measurement in which formation fluids are physically withdrawn and retrieved to the surface for examination. The sequence of tool movement required to measure formation pressure begins when the formation tester is activated at a selected depth. The sampling system shown in figure 2 illustrates how this measurement is made. Prior to activating the tool, the pressure gauge measures hydrostatic mud column pressure. Upon activation, the equalizing valve is shut and the packer and probe are pushed against the formation. The tool is now set. Within a few seconds, the piston of the pretest chambers begin to withdraw, causing fluids from the formation to flow into the tool through the packer and probe assembly. The pretests are done sequentially with a small volume of fluid drawn into chamber 1 over about 15 seconds, followed by a similar volume flowing into chamber 2 at a higher flow rate. Upon completion of the pretest, a sample can be taken or the tool can be retracted. During retraction, the equalizing valve is opened and the pretest piston expels the fluid taken in. The tool is now ready for the next test depth. Different vendors may use variation of this design that incorporate a single pretest chamber of fixed or variable volume.
The logging unit lower the logging tool on conductive wire line into the well to the depth of investigation. The unit then reel in the tool. As the tool comes up the hole, it detects certain aspects of the formation. It sends the information through conductive wire line to the surface. On the surface, computer of logging unit record the information. The computer then prints out the information, which is the log. The log can examined by the well logger to get the information to determine either oil or gas exists in the formation. Here is a logging truck. It contains the computers. The wireline on the reel and control the logging operation works. In offshore, instead of logging truck, the equipment is installed in small house. Wireline controls which allow an operator to lower, stop and raise the wireline, and the computers record and display the information from the logging tool through the conductive wireline. The well logger can choose many types of logging tools, plus they can run some of the other tools in combination. Logging company groups logging tool into 4 broad areas: electric, nuclear, sonic, and others.
Pressure measurement. During the pre-test sequence, pressure is monitored with the tool sampling system. The schematic drawing in figure 3 shows the pressure typically recorded during the pre-test sequence. In this figure, time is shown as increasing to the right and pressure and flow rate are increasing upward. Initially, and when the tool is being set, the equalizing valve is open and the recorded pressure is hydraulic mud column pressure. During the drawdown associated with the first pre-test, the pressure is observed to drop, stabilize and further decrease during the second pre-test. When the second pre-test is completed, the flow stops and the pressure builds up to formation pressure. Figure 3 illustrates the flow rates associated with the first and second pre-test. Actual formation pressure can be taken when the pressure becomes stable or can be estimated from the character of the build-up if it has not yet stabilized when the tool is retracted. We move to the next figure. Figure 4 is a typical log recorded by a formation tester that has a single pre-test chamber. In the left log track, the solid curve represents the pressure detected by the gauge within the tool sampling system. Time is increasing downward along the log. The hydrostatic mud column, drawdown and formation pressure are clearly detectable. The sudden increase at about 105 seconds corresponds to the tool retraction and opening of the equalizing valve. On the right are 4 narrow tracks displaying the thousands, hundreds, tens and units digits of the measured pressure. For example, after 80 seconds, the formation pressure is 3927 psi. It is obvious on the units track that the pressure is increasing and actual formation pressure has not yet been reached.
Moving on to the next section, let's talk about the advantages and disadvantages of using wireline formation tester. Advantages: less time taken to obtain results, less expensive compared to DST, and there are multiple zones that can be tested on a single run into the hole. After that, we'll talk about the disadvantages. The data obtained has considerably low quality. The radius of investigations are normally smaller than in well tests and DSTs but larger than cores and logs. And the radius of investigations within a range of tens of feet radially and vertically along the well bore.
It's been a long day without you, my friend, and I'll tell you all about it when I see you again.